points. These are ones that we these are ones that we talk about each session. And I think it's great to just have a reminder that we really try to honor, encourage, acknowledge. You can see some of these really, really strong words that really speak to content and character for these sessions. Be present and really uphold commitments. So I'll let you take just a moment to look at this, but it really helps to create a safe space for us to communicate and interact. So thank you. So here's information about this session. I do believe we'll be reporting, but if you'd like the information for the number as well as the formal name, here you go. And then here are the learning objectives for today. We're gonna be learning about innovative strategies. We're gonna hear many ways to reduce heat transfer for building envelopes, how to select and incorporate energy efficient systems, and then also look at specifying high efficiency mechanical systems. So really great relevant information to all of us in the building profession. All right, well, thank you so much. And we're so happy you're here. I'm gonna hand it over to Matt, who can tell us who's gonna be doing some speaker intros.
Thanks, Ellen. Hey, everyone. Matt Boetzel, project manager with Carlton Hart. I volunteer with Ellen and Elisa and Colleen through the AIAO COAT, and with Ashley, Alex, and Ryan through Zero. I'm doing intros today. So first on the list, Ashley Haight, our fearless program manager at Zero Coalition. Ashley does it all: coalition building, strategic planning, project management, relationship management, outreach, recruiting, onboarding. Everything runs through Ashley. And active climate justice advocate, committed to filtering everything we do at Zero through an equity lens. So Ashley, thank you for being here. Second on the list, Alex Boetzel, head of residential innovations at Earth Advantage, and before that, over 16 years in the design build field, focused on net zero design and construction, certified passive house professional, currently on the board of Passive House Northwest, previously a member of the City of Portland Design Review Advisory Committee, and also heavily involved in Zero Governance and Steering Committee, Advocacy Committee, and Technical Committee. And finally, third on the list, Ryan Shanahan, self-professed building science geek. And check out Ryan's Retrofit podcast if you haven't already. So Ryan is the Zero Energy Retrofits Manager at Birdsmouth Design, previously about 13 years with Earth Advantage, sustainable architecture, engineering, building, craftsmanship. Also certified passive house, rater, verifier, HERS rater, and Ryan also volunteers on Zero Governance and Steering and Technical Committee. Everybody here, thank you for sharing your time with us. When you have questions, please plunk them in the chat. Anything you want addressed immediately, just maybe mention, hey, clarifying which item you might want Ashley, Alex, and Ryan to talk about, or anything that might be able to wait until the end. I'll keep an eye on the chat, and we'll try to address stuff in real time that wants to, and then we'll hold everything else until the very end. Again, thank you all for sharing your time with us today. And now I will kick it over to you, Ashley.
Thank you. Just showing an agenda here. Thanks, Matt, for those great introductions, and Ellen for the announcements. And we're going to do a short Zero Coalition overview that I'll do for you, and then jumping into the main content, the overview of the 7 steps resource guides. So they're the cost-effective steps to zero energy in new buildings and retrofits. That Alex and Ryan will kind of alternate going back and forth on each step to give you some guidelines over that. We'll have Q&A, and then at the end, we want to talk a little bit about our advocacy campaign and how you can get involved if you're interested. So we can go to the next slide. So what is the Zero Coalition? Yeah, so we are over 40 members now. We started in late 2017, and what sets us apart from other coalitions is that we bring together businesses, nonprofits, and local governments to make our voice stronger in decarbonizing the built environment from an equity-centered perspective. You can go to the next slide. So just put some things we do on here. So, everybody's close to the sustainable building industry that's in the coalition. They've all agreed to our justice, equity, diversity, and inclusion priority. And we've done everything from training our members, and training a general audience about those topics, to specific trainings like this for architects and engineers. So we create tools to bridge the gap from inefficient buildings to cost-effective, high-performing, and highly efficient buildings, and increasingly zero energy buildings. So yeah, I could go into each committee and everybody's work, but I'll leave you to contact me. My information will be at the end there. If you have specific questions or interests, and I'd love to set up meetings with anybody that wants to know more, because we are looking for new members right now. You go to the next slide. And this just talks a little bit about our mission that I covered, the equity-centered approach to decarbonizing buildings in Oregon. Excuse me. And it shows some of our members. So when I say nonprofits, it's such a wide range from, the Contractors Association, Latino Built, to we've got the Green Energy Institute from Lewis and Clark Law School, Climate Solutions, Environmental Center in Bend. We're trying not to be just Portland Metro centered. So we have cities from all over the state as well. And Multnomah County is a member too. And then the businesses are builders, architects and suppliers, just everybody that kind of fits in, that cares about our mission as much as we do. So go ahead. And why should you become a member? These photos are from our all-member meeting recently at Sarah Architects' office. It was a beautiful retrofit in the Galleria building downtown. And we got a tour, as well as a great presentation about Portland's climate action plan. But if you join the Zero Coalition, you broaden your organization's reach on your policy issues around climate and built environment at a state and local level, sometimes national as well. We leverage your expertise, gain insights and guidance on codes and processes, and participate with a group of experts to work on collective solutions. So basically, all that is to say, you get to use your expertise and your voice to try to make positive change. Next slide. And a few other reasons. You can help shape our priorities and participate in these gatherings that we have, and network and access our members only benefits of tools and opportunities, trainings in our newsletter. It's a lot of members have mentioned that one of their favorite things about the Zero is being just kept in the know and what's going on with the building codes, what's going on with the legislative session and specific bills. So we are happy to keep people up to date on all of that information. Next slide. And the first plug for the Advocacy Committee is this is our newest committee, and we're really excited to get more involved in bringing voices from the sustainable building industry into the advocacy world. So we're finding that with this type of legislation, there's plenty of people that are already there from nonprofits that are, consistently advocating for these types of policies. But what they're not seeing as much of is technical experts. So it's really valuable to make your voice heard for this kind of advocacy. So we made a little QR code to connect you with a short survey. And that survey, it lets you tell us your specific interests, your expertise, and the types of advocacy that you'd be interested in, because there's many different levels of getting involved. You don't have to necessarily meet with a legislator one-on-one. You could submit written testimony. You could do verbal testimony in person in Salem. You could do verbal testimony online, virtually. So there's also chances to write opinion pieces for editorials, to write blog articles, give us social media content that supports these bills, or just share our social media content to raise awareness that, you know, have more people asking for this. That's really important to show legislators that people are paying attention and we're pushing to move forward. Next slide. So with that, I will turn it over to Alex and Ryan. I think Alex is up first with the first step to new buildings. And I'm excited for you all to hear this presentation, and that these resources are available to everyone for free. So, you know, don't forget that you can take away, we can send out after the presentation the slides, and also like PDFs of the 7 steps, so that you can use them in your own presentations if you'd like. You know, crediting us is nice, but we don't have any kind of license on this because we just want it to be spread as far and wide as possible. So yeah, turn it over to you guys. Thank you.
Awesome. Thanks, Ashley. I'm Ryan. I'm actually going to start. So I'll be mostly going over the retrofits guide, and Alex will mostly be going over the new buildings guide. And I like that this slide is how we start out, because there's some obvious overlap between the two. And so I really wanted to highlight, while we're looking at it here now, that it's really just steps 1 and 6 on the retrofit guide, which are totally different from the new buildings guide. From another perspective, you could say that the new buildings guide is totally different because it talks about optimizing and designing the building, which is something you can't really do in a retrofit scenario. But lo and behold, the sort of basic principles that you learn through trainings like Passive House, et cetera, is what you'll see here, right? Where it says, like, let's focus on the shell first and work our way into the mechanical systems, and then things that use less and less energy. So it's really important to keep in mind that the way these are set up is that you do the steps in order to gain this cost effectiveness. It's often that things happen out of order, which is what can send costs spiraling. So I really wanted to emphasize that point. And I also wanted to mention that both Alex and I are co-chairs on the technical team that put both of these guides together at Zero, and we would love new technical team members. And so get in touch with either one of us if you're interested in joining. Let's see the next slide.
All right, thanks, Ryan, and hello, everybody. So the first slide here, this is like the overview of the 7 steps, and I think what's important to say is, like what Ryan mentioned, it's a roadmap to get to deep energy efficiency. So these steps are applicable to any aspirational goal for a project that likes to do that is pursuing high performance and deep energy reductions. And what's interesting here is, like Ryan was mentioning, we're really focusing on load reductions first, and then we make the step to get to zero energy with renewables. And so that will be a reoccurring theme as we go to the steps. And I think, again, the format we chose, right, is we're going to alternate just to see what the similarities and differences are between the 2 steps.
Awesome. I don't have too much to share here. I think we should just dive right into the first step.
Okay. Okay, so on a new construction project, like, Ryan was saying, we have a blank slate, like we have boundary conditions, but there's a lot of opportunity potentially to shape the building, and have other levers that, on a retrofit project you might not have. But what is critical is that really that the goals are set as early as possible, right? So similar to what Ryan was saying, the later in the process we wait or steps are out of sequence, it becomes significantly more expensive. For example, there's projects who have, like a building massing that's not favorable actually to, for a high performance envelope, or less favorable. And that precludes a project from really achieving the step that but then the project is too far down in design to really back that out again. So setting the goal early is key, and kind of tracking the goal to ensure that you meet it is a lot easier than trying to increase efficiency after the fact, right? The other thing is that maybe it's good to point out here at the first step is you see this is organized in a certain way. So we have on the left, we have the steps as we go through them. On the right, we're talking about the purpose, like what are we doing? Like what's the purpose of that step and why are we putting it in this place? And some strategies how to get there, right? So in this case, for example, like we're scheduling goal setting meetings early on with the entire team, and many of you who've worked with a energy trust are familiar with our design assistance meetings and things like that, and there is true value to this. No matter where the project comes out in the end, I would almost guarantee you that it would be more efficient than what it would then without these meetings. And it's really important to have as many voices at these meetings as possible, because if you get the expertise from engineers, probably ideally key traits that can really help to find the most cost-effective way to achieve the goal that you're setting out to do.
Awesome. So on the retrofit side, this step is something I've been asked about for years. I've been presenting on how to do new construction zero stuff for years. People always ask, what about retrofits? What about the existing building stock? And they're often surprised because this answer is pretty straightforward, but it should always start with an assessment by a pro. Existing buildings are all different. And so what the pro can help you do is figure out maybe some of the things that are already working for the building and what some of the biggest limitations are, and maybe where to point most of the energy at from an early stage. So having that assessment by a pro is not only the first step, but you'll be working with that pro at assessing all of the other identification upgrade opportunities, as well as developing the implementation plan later. So I think if you took anything away from this on the retrofit side, it would be absolutely find a pro to work with to do that audit and go from there. A bit more into the weeds, it's super important to work with a pro that's going to come out and audit the building with diagnostic tools. So I like to call it a clipboard audit if somebody comes out without diagnostic tools, which can be helpful. But when you're looking to make a deep dive, like getting to zero or zero energy ready, for example, it's pretty important to do this step with diagnostic tools. So we're usually talking about a blower door, but we can also be talking about duct testing, bath fan testing, and various, thermal imaging cameras, et cetera. And then, of course, you're going to see this second bullet point under strategies repeated a bunch. Consider electrification at every step of the way. So just like Alex was mentioning on step one for new construction, there are some opportunities for electrification you might find if you start asking the question early enough. There are definitely times where you've gone sort of too far and it becomes a potential roadblock if you wait to do it later. And then the last one is just potentially looking at a phased approach. If, a very real customer doesn't have access to all the money it would take to do this big retrofit all at once. Working with the pro on what kinds of things to incorporate into which phase and why can be a really important step early on.
Right. Yeah. So it's clear, right, that there's more constraints on a remodel than on or retrofit than a new construction. And so you need to identify those early, even though on certain, like one clarifying point too is like we're showing homes in the graphic that is really for ease of illustration. These steps apply to single family, multi-family commercial projects just as well, maybe slightly modified, but really it's just for the ease of identifying those opportunities. So basically, digging into step 2 now, I alluded a little bit to this in step 1, but optimizing building shape and orientation is really, it's essentially a no-cost step, right? So this is oversimplified. We have constraints with like setbacks and height limitations and things like that. But again, like when we're starting to first putting pencil to paper, we have an opportunity to really try to identify like what is the optimized orientation, right? So we want to have, depending on what your goals are, optimizing daylighting, optimizing heat gain, maybe beneficial solar gain in winter, but keeping out unwanted heat gain in summer, right? So that helps us with orienting the building, fenestration, shading devices. So all of these are strategies. And some simple ones, right? So the volume to surface, the surface to floor area ratio. If you have a more compact building shape, we have less external surfaces that will that are exposed to heat gain or loss. So optimizing that shape is ideal to ideal starting point. If we are keeping in mind that we do want to go all the way to on-site renewables, right? We can take that in considerations as we're designing the roof, right? So if it's a slope roof, we want to orient it to the south. If it's a flat roof, there's less opportunity. So, but maybe equipment placement on the roof can play a role. But just keeping that in mind from the day 1, even if it's not maybe in phase 1 or in the initial plan, something we call as designing solar ready should really be always a consideration. So even if you're not considering putting renewables on the roof today or right now or in the scope, someone hopefully along the line will do that. And so keeping, it's much easier to prep for that with some conduit and some space requirements than have to open up walls and putting in the infrastructure later. So that's definitely something you want to keep in mind for any project again. We're saying orient the building east-west, which again makes it a lot easier to manage unwanted solar gain to the east and west, whether we have of our building front towards the south or north, which is not always not always the case, but if you can, we should keep that in mind. We talked about window shading. Energy modeling is another one that's similar to the goal setting, which is really part of it, is we should consider energy modeling as early as possible, but something that is like a shoebox model. So if you have your basic massing, have an energy consultant or energy modeler build a shoebox model. So you understand okay, what's the striking distance to our goal, whatever that goal is, if it's 0 or a certain benchmark, architecture 2030 or something else, is have a shoebox model, understand what is your striking distance, make modifications now, because these are big moves that we're doing right now. And that's easier early on, and you be, then trying to make that up with, our values or equipment efficiencies in the end, if you have the opportunity to maybe, change the massing a little bit.
Alex, I'm stoked that you mentioned that the diagrams are homes, but that these apply to all building types. Another thing that's really important to mention is that not only do we have all this info on the Zero Coalition's website, but we have resources for each of the steps that are broken out by those 3 different building typologies. So there's some additional info for each of the steps that's broken out into single family resources, multifamily resources, and commercial resources. So for step 2 on on the retrofit, sorry, you want to identify envelope upgrades. So this is where you're going to start to see these two retrofit and new guides overlap a lot. But I want to make sure that we call out some of the differences here. So especially in retrofits, you're going to find that heating and cooling energy typically dominates the energy consumption. And so, identifying envelope upgrades can be one of the most cost-effective ways to reduce that consumption and have major effects on, comfort and all sorts of other host of benefits. You absolutely want to prioritize air sealing often before insulation happens. And that's simply because air sealing is the most cost-effective way to reduce consumption. And so using a blower door test like you had from that first step is a great way to figure out where the leaks are. You can actually use a blower door to do blower door assisted air sealing, meaning you can do air sealing while the blower door is running and help you see what kinds of things are making what types of impacts in real time. Clearly defining and aligning thermal boundaries between inside and outside is something I see a lot in older homes in particular, and I wouldn't be surprised if this problem persists in other building types. But what I mean by this is, when you go into somebody's basement, perhaps, and it's, not finished space, you ask them, is this inside or outside space? Is it heated space or non-heated space? And you often find it like, geez, I don't know, a wishy-washy answer. And it's not that the homeowner is stupid. It's that it really is a wishy-washy buffered space that's kind of not totally inside and not totally outside. So establishing early on, if the customer wants that space to be inside or outside, and what the benefits of one approach versus or another are things you can do at this early stage that can have a pretty large impact. And things like, does it make sense to create a conditioned crawl space, or does it make sense to create a conditioned attic? For me, often that decision is driven by whether or not ductwork runs through those two spaces, but there could be other reasons why you'd consider those two things as well. Maximizing insulation levels is something that has pretty severe limitations on some retrofits, right? So I'm thinking of things like 2x4 wall cavities, or even 2x4 like rafter bays, where you're really limited to what you can do. So I cannot stress enough that when you have gained access to one of these spaces, it's imperative that you do the best you can insulating it while you have that access, because it's very unlikely that you're going to create that access just to insulate later. Which is another great reminder. There's a whole bunch of things that in the retrofits world that are when in Rome scenario. So you'll see that point made over and over again throughout this guide that says things like, when you're re-siding, consider adding exterior insulation. So there's a whole bunch of situations where, it's potentially a major expensive upgrade to get into one area, but if you have to do it anyway, are there other opportunities you could gain by having that access to those spaces that don't usually provide access? You can optimize window performance with storm windows or Indo windows in a historic window situation. If the windows aren't really nice and they're single pane, crappy old windows anyway, absolutely consider upgrading to a triple pane in that scenario. But I really wanted to point out here that there are some pretty neat old windows that have real value in keeping around. And so there are ways to kind of have your cake and eat it too, where you keep those windows, but add storms on the outside and other window type materials on the inside to increase the performance.
All right. So the equivalent to the new construction, again, like we're talking about the envelope first, so load reductions, Ryan mentioned heat loss, heat gain, HVAC being one of the bigger loads. And so increasing envelope performance, which insulation values, air tightness, better fenestration brings down HVAC loads. And he also touched on something I think that we cannot underestimate at all, which is like these secondary benefits, right? Comfort, health, and guess what? Resilience is like a big topic for us. So heat dome, ice storms, all that we're addressing, like we're setting out right now to reduce energy and carbon emissions, but there's all these benefits that we're basically getting while we do this work. And so the key piece is, I think, everybody understands insulation levels, right? We know that an R20 is better than R13 or 30 or 40, if you go to passive house levels. Air tightness is really something that is kind of like not really common vernacular in our state. We see codes catch up to this in Washington. They have a code on air tightness. And we have certain pathways that include air tightness goals for code compliance, but it's really something that addressing that early on is critical, specifically the bigger the project is. And again, coming from the passive house world where air tightness has been indicated as a big opportunity and a really hard and fast goal. I really understand that that is somewhat of a litmus test for your team and your project, right? So air tightness details, right, that we have to define can be great defined. If they're not executed well, it won't be airtight, right? On the other hand, you can have amazing craftsmanship on site, but if the details are faulty, you won't be able to get your air tightness goal. So again, that speaks to the early integration of trades and design team to make sure that these goals are thought through. So for example, if you as a designer have an air tightness strategy, run it by the general contractor, like, this is what I want to do. Are you comfortable with this? Do you understand what we were trying to do here? Have you done it before? And get their input, which is true for really any of the measures that we're looking at. Getting feedback from the trades does tremendous things to the cost effectiveness of the project. We have seen this in things like integrated design and things like that, where we were understanding like early collaboration is key, and this is true for the envelope considerations as well. We talked a little bit about window to wall ratio is like, again, fenestration often less performing than wall, the orientation of the windows, and making sure that, again, that our thermal boundary is consistent. Same with the air barrier. And there's like, this classic kind of idea of the pencil, right? If you're in any section or any plan view, can put a pencil down and follow your thermal boundary or your air barrier without having to lift the pen, it is complete and contiguous. It's a simple test, but do it to understand that makes sense. And anytime like you change direction with those pencil on your drawings, that is a detail that you ideally define. Okay, what happens here with my thermal boundary and my air barrier? Classic ones are roof to wall, wall to floor, penetrations, things like that. But whenever you or balconies, whatever it might be, whenever you have a change, like what happens here, like with my envelope, and am I achieving my goals?
Alex, Ryan, this is fabulous. No one likes the timekeeping person, and that person is me. I'm noticing we're on step 3 and it's 4:30. I just want to make sure we have time to get through everything.
Okay, we can speed it up a little bit. Step 3 on the retrofit side is identifying mechanical system upgrades and electrification opportunities. I think this one's pretty straightforward here, but it's important to recognize that this is after you have tuned up the shell. And so I want to stress here that you should take these upgraded R values, U values, etc., to mechanical system contractors and have them use software to determine the system sizing. This has been said since I started in my career, and it's still something we're pushing for, and we're still getting pushed back on. So that's the thing that I really, really wanted to emphasize here is demand that this gets done with the HVAC contractor. And there's a bunch of stuff in here about water heating opportunities too. And I think hopefully a fair amount of people here are familiar with heat pump water heaters. And so I just wanted to mention, I think the challenge of heat pump water heaters is that the conventional ones cool the space that they're in and make a little bit of noise. I'm really excited by like these Senko 2 systems, which have they're split, you know, they have an outdoor unit and an indoor unit. I think that's likely the future, and we'll see more systems like that going forward.
Similar on the new construction side, now that we've brought like loads down by, you know, improving the shell or passive measures, right? That doesn't cost us operational anything. Now we want to optimize the HVAC equipment. And I think it's key, and you will recognize a theme here. You need a professional who understands what you're doing, right? So if people try to size systems based on, we have always done it like this, they will oversize the equipment most likely, and it will not perform as intended, right? And so bringing in the right professionals that understand what you're trying to do at the right point is key. The one other thing to say, maybe to the mechanical side, you know, just like Ryan was mentioning, electrification is one. Like we will be able to offset, you know, any operational energy that we're any energy that we're consuming on site with renewables. That's the more difficult with fossil fuels. They're also significantly more efficient. You know, heat pumps are 3-4 times more efficient than gas equipment. We are having some kinks to work on a hot water side, but we're working on this, and there's, you know, excellent projects out there that have been successful.
Awesome. I wanted to add something that I think in the green building sphere, we've seen a whole lot of emphasis on upfront emissions and or embodied carbon. And something that I think is being overlooked is the outsized impact that refrigerants have on climate change. And so it's pretty amazing how you can squash the amount of refrigerant needed for these buildings by creating a better shell. So that's yet another benefit of reducing the load, is less refrigerant is necessary, which in theory lends itself to less leaks, because the current refrigerants we're seeing have an impact on the climate about 4,000 times worse than CO2. So it's a major deal when a little leak happens. Step 4 on the retrofit side is identifying efficiency and electrification upgrades for appliances, lighting, and other equipment. Some pretty straightforward advice here. Look for Energy Star ratings on appliances. Look for water sense on plumbing fixtures. One that I really like to emphasize is that Energy Star has a most efficient products list every year. So it isn't just the stuff that meets their minimum threshold, but it's stuff that's performing at the top. And then lastly, you can reduce plug loads with a whole bunch of new smart tech. And I'm sure that you all are seeing what kinds of reductions you can see with better computer technology as well.
Right. So appliances and lighting, the same on the new construction. We're working our way down, right, from the biggest loads to smaller loads. You know, lighting has been pretty efficient now. We see 100% LED everywhere. But the appliances, understanding what we're using and how we're using it, just keeping an eye on it. If we're talking about multifamily, we might have 50 refrigerators who are all running more or less 24/7. You know, so any 50 kilowatt hours that we can save across the year for a refrigerator adds up quickly. Same recommendations. Energy Star is a great resource. And then smart controls. We're also going down the level of complexity, right? We talked earlier about like simple upgrades like insulation, very dumb but effective measure. So we're now down really just squeaking out the last little bit of efficiency with controls. So make sure that you emphasize on the right place to begin with and where you put your money. Smart controls are great, but they really kind of like, okay, now we're having the last little bit that we have to squeak out to meet our goal. So that's really reflects the intention behind the priority and behind these steps and the sequencing that we're proposing.
All right, step 5 for retrofits is evaluating solar PV viability and considering battery storage. I think the solar PV part's pretty straightforward. Battery tech is expanding fast, and it's a really exciting thing right now. I think what we're able to do with batteries is there's a lot more than just power your home in an outage, for example. It might allow buildings to utilize clean power going into the nighttime, for example, when a building would typically start tapping into the grid. And I think, you know, from a resiliency perspective, the more electrified everything is, the more connected everything is, and the smarter everything is, the more opportunities we'll have to see sort of clusters of panels and batteries that all sort of work together, work with electric cars, et cetera. And bidirectional charging from cars is another really exciting thing, where we maybe power our homes off of our cars if we don't have batteries. So there's just a whole ton of exciting things happening here, including some really cool smart breakers and smart panels that allow you to do a hell of a lot more than you were able to do before, including monitoring, which we'll talk about at the end.
So yeah, so we're really what we're saying, right? We're arrived at this stage where we reduced all of the loads as much as possible, and now we're adding active systems that kind of offset the rest. Again, on a new construction project, talk to a consultant early on to understand like what are the opportunities, right. So if you don't have solar access, right? If your building is shaded by trees or higher buildings around, then you can do community solar is an option that's viable in Oregon now, where you basically get a share of a solar system that it has like optimal exposure, and you're still offsetting 100% of your, or whatever much you're signing up for, of your load. So that's an important piece to understand, like, okay, you're not limited by what you can generate on site. We have other options now as well. One thing to note about batteries is most people don't know, you don't have access to, you know, the power that the PV generates in a power outage if you don't have a battery, right? So that's a safety thing. Like PV systems have to power down in a power outage to protect line workers. You know, they don't expect something feeding in, so you have to have a battery to take advantage of this. This is, you know, most people don't understand that is the requirement. But so if you are looking for resiliency through PV, you have to include battery storage.
Awesome. I also wanted to mention on the battery and solar side that I just saw, I think it was just yesterday, that there's some pretty cool new tech where you can split a large solar system amongst different apartments in a whole myriad of ways, including splitting stuff up in real time depending on demand. So there's just so much really cool stuff coming down the road that's going to allow us to utilize this clean power in better and better ways. So this step 6 on the retrofit side is coming right back to that energy auditing pro that you hired in the beginning, where you're developing the implementation plan. And this one is hypercritical when it comes to budget limitations too. But I just wanted to emphasize that there's so much here that has to do with the specifics of the building that we're talking about, the things that make it different from the others, that this step could take quite a while, and spending time on this step is an important one.
Yeah, so step 7 then is commissioning the systems, right? If we have selected like high performance HVAC equipment, battery storage, PV systems, controls specifically, and the more intricate they are, the more complicated, we do need commissioning. It's kind of a key point that's still underemphasized. The system doesn't come out of the box the way you want it to perform. It can do many things, so it's set to something at some point in factory settings. And if your HVAC equipment isn't tuned to what it's supposed to perform, it will not perform as you expect it to do. And again, the more complicated the systems are, the more important that is. If they're interconnection between system like heating, cooling, and ventilation and things like that, you have to make sure that you get the right flow rates, the right heating loads, ventilation rates, and you won't know if you don't commission it. So super critical. If you can monitor your loads afterwards, that's great, because then you can see, is my building doing what it expected to do, or my home, or is there anything that I need to intervene to get the performance that I was expecting?
And go figure, it's the same step on retrofits. I like that we added this last bullet point under strategies, where if you haven't reached your target, return to step 6. So I just wanted to emphasize that one, that sometimes it takes some rejiggering to make it happen.
All right. So we're open for questions. I don't see any in the chat. Feel free to place them now. While you do that, I just want to emphasize again, any high performance project benefits from these steps. There's logic behind the sequence of the steps. So try to follow them. It's not always possible, specifically in a retrofit scenario. Like when you have those opportunities, like when does the siding or cladding needs to be replaced, or when does HVAC equipment need to be replaced. But having a plan is the key early on. What's my goal? How do I get there? That's just the key to success.
Hi, this is Jim. Can you hear me?
Yes.
I've been doing some near zero energy buildings probably for almost 15 years. And now it's becoming the case that in order to replace a radiant heated or cooled building with electric, we need the liquid or the air to liquid heat pump, which, Daikin has been making Altherma for quite some time, but there's been a lot of problems. And I'm having a lot of trouble right now in that with a couple of new projects where I want to do all electric with radiant heat and a domestic hot water portion. Do you have any recommendations? I've been looking all over the place. There's a lot of stuff available in Europe and quite a bit in Canada, but not a whole lot around here, and not a whole lot of contractors wanting to deal with it.
I can handle this one. That's a great point, and it is a known problem. And I'm just starting to see some new stuff through Small Planet Supply. I would guess that their competitor 475 would also have similar stuff. But you're right that it's largely going to be from other countries. So it's also likely going to be fairly expensive. But I am excited that they're having more options now, because that'll help with various sizing needs and the particulars that you're looking for. So those are my 2 bits of advice: is just look at Small Planet Supply and 475 for some options.
Yeah, well, Mitsubishi seems to be one of the better companies out there for doing a lot of this stuff, and even they have systems that are built that are offered in Europe and Canada that are not offered in the United States. And I mean, kind of frustrating.
The equipment, the equipment specifically that Ryan mentioned is called Space Pack. That's
Yes,
the air to water heat pump.
I've seen that.
You can also, just one thing to keep in mind, which is like interesting on the residential side, if you really try to get to zero energy by reducing loads, you're reducing heating loads, which means that you need to provide fewer BTUs to a space. So if you have a radiant system, you might not notice it's on actually, because your temperature will be 85 degrees. If you touch the floor, it still feels cold. Now, if that's the case, you wonder, do I need to go through the effort of putting a radiant system in the first place, or might be an air-to-air heat pump the more cost-effective measure? Just something to keep in mind. I know I understand how people feel about the benefit of radiant heat, but depending on the level of your efficiency of your enclosure, something changes, right? So we're really like don't need to emphasize heating energy as much anymore, and it becomes less important where do we provide the heat, because it's so few BTUs in the end. And to finish that, if you get the loads down, you can also use efficient heat pump water heaters. For example, the Senko has an opportunity to provide heat pump domestic hot water and radiant if your load is below 8,000 BTUs is typically the rule of thumb. But again, if you do that, you probably want to be really intentional where you provide that radiant heat, maybe like a loop in the seating area or bathroom, because you will not need to provide it all through the house.
Yeah, half of my work is in northern New Mexico, where I used to live, and everyone there wants radiant, and that's one problem. And the other problem is that a lot of this equipment doesn't come small enough. Really, they offer, like Space Pack has this big unit when I want one half the size, and and that includes the heat pump water heaters. A lot of times you can't find something for an ADU. It's sizing is off. Anyway, I'll keep working on it.
Great. There's another question Serena has in the chat, how to sell this. Well, there's two strategies, right? You can say like, yes, certain installation might be more costly, but I also would probably challenge that a little bit. It really depends on what you focus on, your priorities. But you have operational savings. So if you build a house and operate it, maybe you pay some more, 5%, 10%, depending on what it is, which I think there are strategies to optimize that. But then for the rest of the life of the building, you save, right? If that's not enough, the financial calculation, let's talk about, the secondary benefits. You will be super comfortable. And we're not talking thermal comfort. We're talking acoustical comfort too, right? Triple pane windows and extra insulation, keep it really quiet inside. We're talking about resilience, healthy indoor air if you have mechanical ventilation. So there's all these other benefits that might be particularly interesting for homeowners, right? In fact, in my practice, I've seen, the first people interested, like, I want to save energy. And now there's people like, especially after the heat dome, like, how do I survive a heat dome? And, oh, it's efficient too. That sounds great. But I want to just be comfortable doing this weather events.
So she also adds, you bring financial calculations to the conversation. This is a tricky one. I like to remind a lot of my clients that ask these types of questions, like return on investment, payback periods, et cetera, that we live in a temperate climate with cheap energy. So a lot of this stuff is not going to pay for itself in a quick time period. So I try to hit at all of the more important things that Alex might have described as, ancillary benefits, et cetera. But I think a key component that's often missed is basically the idea of connecting high performance, green, sustainable, whatever you want to call it, with quality, because everybody wants quality, and this stuff simply translates to higher quality. It doesn't mean that they have the money to pay for it per se, but I think there's something that shifts when you just start talking about these things as better and not just things that save energy.
And then maybe one more aspect is, we talked about setting goals early on. So you might have programmatic goals, but you have other goals, and then matching those to the budget. You can argue, hey, if I build a home and I build it to zero energy, and then I go in later and strip it of triple pane windows, insulation, high performance equipment, that's cheaper. But if you start out to design to a certain budget, a certain performance level to a certain budget, the question becomes, is it more expensive because we're still delivering the program to the budget, right? We just happen to have it with, as efficient as possible. So what I'm saying by this, it's not a completely fair conversation to say, what does this add to the project? Because it's baked in, it just becomes part of the project. And maybe that helps to frame the conversation slightly different. As like if it's looking at the home as a whole and as a system, and not like these individual components, and what does it deliver?
The other bit I'll add is that, a key component of sales that's often overlooked is that this is a cheesy expression, but selling isn't telling. What it really means is you want to be asking questions and doing less talking. So the goal of the question asking of this, theoretical client is to find out what's important to them, find out what problems they might be looking to solve, because it might not be energy savings. It might not be monthly savings in dollars. It could be something else that really speaks to them, like health and indoor air quality, durability, resiliency. Like we've hinted at some of these things, but figuring out what it is that makes your client tick, I think can be a really useful tool in the sales process, and really takes you out of the hot seat of having to feel like you just need to talk at them until they agree with you.
Well, this is Jim again. I have another point to ask you. The temptation to do rigid insulation is always there and a big thing, but you have carbon as one of your leading rules here, and poly expanded or extruded are some of the worst things we can put in our buildings in the carbon world. And so how do we get rock wool or polyiso as the preferred rigid insulation? And I also know that some people are working on plant-based panels. Could you comment on all that?
Alex, you want to take this one?
Sure. Yeah, no, I totally agree. I think everybody's aware that like bio-based, really interesting if you can grow it, right? It actually absorbs carbon and is might be carbon neutral or sequestering carbon. So there's wood fiber insulation that's coming on the market now. People are a little hesitant. I'm putting wood fiber insulation on the outside. Like how does that hold up in Pacific Northwest weather? So there's opportunity like that. And yes, like foam products, especially rigid foam product, had a lot of challenges with their blowing agents. They are coming up with better products as well, right? So just like instead of like a global warming potential of a couple of thousands, like XPS used to have, like we're down to a couple hundred or less. So we're improving there too. There's, so you can argue, like mineral wool is has a lower carbon embodied carbon footprint. It's also fire resistance, which might be interesting for some others. There's other strategies. Exterior insulation is a great strategy because it addresses thermal bridging as well. But there's other strategies like double wall constructions or things like that. So depending on, again, this I think this goes into the goal setting early on, and then prioritizing like where we're putting the emphasis in understanding what resources do you have to understand a product. Like, so EPDs, environmental product declarations, can tell you what the impact is of your product. Very few still have those EPDs, but it's a great way to like educate yourself and your clients around what are our options and how do they compare as one of the many factors when selecting material. And that's true for finished material more and more as well. But I think the main rule is like, is it bio-based, or how processed is something? The closer it is to its natural state, the lower most likely is the carbon footprint of the product.
And I just wanted to add to that, from a retrofit perspective, I think, you're often looking at a scenario where you feel like you need to add exterior insulation. And that one more idea that is often not a fan favorite with clients, but I have seen it happen. A low cost approach is, furring in. right? And creating a deeper cavity on the inside versus adding exterior insulation on the outside. And that can be done really cost effectively with, say, framing members that are running horizontally versus vertically, and just really creating a deeper cavity. And then that allows you to use plant-based stuff like cellulose, for example, right? So awesome. I think we got to everybody's questions.
And we are at time, it looks like. So thanks everyone for joining us today. Matt, are you going to take it from here?
And this is the point where I usually kick it back to Ellen to close this out, but Ashley, Alex, Ryan, thank you. I know you pulled this presentation together on relatively short notice. Really appreciate your time and expertise. Ellen, can you close us out and take us home?
Yes, I will bring us home. Thank you so much, everyone. Hopefully this was really important information that resonated with the group, and we really appreciate your time to present. And thank you so much. Our next event is on May 10th, and it's going to feature the AIA 30 award winner. So we look forward to joining you then. So thanks so much, everyone, and I hope you have a great evening.
Thank you. Thanks for joining us.
All right. Bye-bye.
Bye.
Bye.